Hello viewers, in the last 2-3 programs we have discussed about the basic electronic components and the power electronic components. Here in this program we are going to discuss the general purpose ICs. Here we have collected some of the ICs which are very much used in the field of power electronics. Now as we discuss the general purpose ICs, as the name indicates, IC means integrated circuits, and integrated circuit means it has lot of components packed in one unit. Naturally the device is very compact. So there can be 3 types of ICs. One is SSI, small scale integrating circuits, the other one is LSI, large scale integrated circuit, and the third one is VLSI, very large scale integrated circuits. Naturally as the name suggests, this will have lesser number of components, this will have much more number of components, and this will have very large number of components such as microprocessors and all. Now in the name of general purpose ICs we will discuss here some very important ICs such as op amp, timer, optocoupler, regulator, and there could be another which is SSD, 7 segment display. To start with, let me explain the first IC which is op amp. Op amp the full name of this is operational amplifier, and this is basically a differential amplifier. The device is used for many functions, and as the name indicates, it can perform many operations such as addition, subtraction, integration, differentiation, and so on. That is why it is a general op amp device. Now generally in the market we have one IC number 741 which is very commonly used as op amp. Now before we go in detail, we have to know a little bit of ICs, its construction and pin configuration. If you look at an IC, you will find that there is a groove or sometime a dot, and the numbers are like this: 1, 2, 3, 4, 5, 6, 7, 8. Here are the pins. You see, I have one in my hand. You can look at it. This is an 8-pin IC, and this is nothing but 741, an operation amplifier. Here also you will find that there are 1, 2, 3, 4, 5, 6, 7, 8 number of pins. So it is like this, 8 pins. Now one important thing is you have to know its configuration. If I have a groove or have a dot, I will put it like this, that the first terminal will be 1, and then we have to go anti-clockwise. Then it will be 1, 2, 3, 4, then 5, 6, 7, 8. Now every pin has a significance, and it is an input or output of the device. In case of 741 we can have like this, One is ON, this stands for offset null, this is negative input, this is positive input, this is minus VCC, this is again offset null, this is output, this is positive VCC, and this is NC. NC stands for no connection. Now I know my pin configuration, I know the inputs, that is, I will repeat, pin number 1 is offset null, pin number 2 is minus input, pin number 3 is plus input, pin number 4 is minus VCC, 5 is offset null, 6 is output, 7 is VCC, and 8 has no connection. You see, I cannot have an IC like 7 pins, so it has to be 8, that is why, but 7 are only used, 8 was not used, therefore no connection on pin number 8. Now I will try to explain what are these inputs or outputs. Of course output is very clear, this will give you the output of the IC, which is 741. Now you clearly see that there are two inputs, one is minus input and the other is positive input. There are two supplies to it, minus VCC and plus VCC, and there is no connection 8, and that these two terminals 1 and 5 stand for offset null. Now what is offset null? Offset null is, before we are going to use this IC in a circuit, that maybe that there is some noise or level difference in the circuit itself, then in that case we have to balance the circuit, and for that balancing we have to put a potentiometer between 1 and 5 and set the value such that the input outputs are all balanced. That is known as offset null. Then negative input and positive input, I will explain it here. If symbolically shown, it will be shown like this. This is 741, this is 2, so it is minus input, this is 3, so it is plus input, this is 4, so minus VCC, this is 7, so plus VCC, and this is 6, so output. Symbolically it is always shown like this. Now here, as I said, it is a differential amplifier. If I can give two inputs to this, the output will be the difference of the two, but many times you will require only one input. When? Let us try to understand it. In case I want an inverted input, I will give it at pin number 2. Whatever I give at pin number 2, the output will be opposite because it is an inverted input. Whenever I want an out in non-inverted type of output, I will give it at number 3 and it will appear, output will appear as non-inverted type. Of course minus VCC and plus VCC are to be definitely given as supply to the device, and then you can obtain output. Now the VCC for 741 ranges from plus minus 5 volt to plus minus 18 volt. What does it mean? I can give a supply of plus 5 volt to plus 18 volt or minus 5 volt to minus 18 volt. Now this was regarding VCC. Another thing is the inputs. There are two inputs here. One is the positive input given at terminal 3, and the second one is negative input which is given at terminal 2. The positive input is known as non-inverted type and the negative one is known as the inverted one. Now what does it mean? If I give a supply here and ground it, only one input is applied. This is, since this is a positive input, the output will be non-inverted type. And on the other way, if I ground this terminal and give a supply here, input here, then since it is a negative input, the negative input will appear as inverted output. So this is, and if I give both, then differential output will be obtained. So this is about the 741. Now when I see, I give two inputs here, how do the output looks like? As I said, I am giving an input supply as say AC. Suppose I am giving only one input, the other one has been grounded and the input is AC. So it is a sinusoidal AC. What is it doing? You see that this is a 0 crossing point, this is another natural 0 crossing, and this is another natural 0 crossing. The device is such that it will sense it here, and since it is the positive half, this is the negative half, this is going to give a pulse like this, then it will come down the negative, it will go like this, and again it will become 0. So, what does it mean? This is the input which is sinusoidal, and this is the output. If you look carefully, you will find the input is sinusoidal, but the output is square wave. Now, we can verify the same thing experimentally also. Now, what I have done here is I have rigged this circuit here with the help of a transformer, step down transformer. I am giving supply through this variac to the step down transformer. So, 6 volt AC is coming as input, and then I have placed this op amp here, and it is receiving plus minus VCC from this supply. Here you see this is the input which is sinusoidal in nature, and the output is square wave. So, the IC, that is op amp, is functioning as a comparator. It is comparing where the zeros are operating. Now, we will take up the second component, very important component, which is the timer. Timer, as the name indicates, is a device, basic device, which will generate times, and naturally it works on the principle of multivibrators. Now, here if you see, we have some of the timer ICs, and normally the timer IC which is used is NE555. This IC is very commonly used and very commonly available in the market also. It works as a multivibrator, both astable as well as multivibrator bistable state. Now, if I draw the configuration, pin configuration, I can show you. This also looks like a 741 IC, and this is also an 8 pin IC. If I draw the configuration, again the groove, then 1, 2, 3, 4, 5, 6, 7 and 8. Suppose these are the pins. Now, these are the pin configurations. 1 stands for ground, 2 for trigger, 3 for output, 4 for reset, 5 for control, 6 for threshold, 7 for discharge, and 8 stands for VCC. Now, what does it mean? Ground means it is to be 0 potential, 8 has to be the potential as VCC. Again, in case of NE555, we have the range of VCC as plus minus 5 volts to, of course, here there is no plus minus, this has to be plus only, 5 volt to 18 volt. This is the range given for pin number 8. Now, I will explain what are these. Trigger, output. Output is very clear that the output of the device will come out from this pin, that is pin number 3. This is 555, you can say NE555. So, output will be obtained at pin number 3. What is reset? The name itself is very clear. When this input is given here at point pin number 4, the device is originally reset, and the 0 condition is obtained, and in that moment the trigger input is given at pin number 2 and the device is enabled for the function. Control. What is control? Let us try to understand. There is a control supply, control signal which is to be given to this particular device for again making its noise and all null. That means we do it with the help of a capacitor. Externally we connect it between ground and control terminal, that is 1 and 5, and usually a 0.01 microfarad capacitor is connected, and which is there, it is used as a filter capacitor to make the noise nullified. Then there is threshold, discharge and VCC. VCC is of course supply. What is threshold? You see, to have the proper status of the device so that it works properly, we have a defined voltage called the threshold voltage, and that is compared with the help of a higher voltage. When that comparison is minimum, then we say that the IC is healthy and it is going to function properly. Now what is discharge? When the output is low, in that condition usually an external capacitor is connected again against this 0.7 and 1, and it is discharged to make the IC proper in condition. So these are the input signals and the pin configurations. I will repeat: ground, that is 1, trigger is 2, output is 3, reset 4, control 5, threshold 6, discharge 7, and 8 is VCC. Now the application, as I said, of the timer which is 555 is for getting multi vibrators. It can be used as a bistable as well as a monostable. Now there are other ICs also there which are not packed in 8 pins. There are 14 pin ICs like this, 14 pin ICs also, and you can see it, there are 1, 2, 3, 4, 5, 6, 7 pins here and again 7 pins here. So in all there are 14 pins. I can draw the pin diagram for it. It will be like this. In this case there will be, suppose this is the groove, there will be 1, 2, 3, 4, 5, 6, 7 here, then 8, 9, 10, 11, 12, 13, 14. Though in this case this is G, then there is no connection, then this is T. I will explain what is this. Then after T it is O, then there is no connection, then R, and there is no connection. Here it is C, no connection, then T, no connection, then D, no connection, and V. What does it mean? G stands for ground, of course NC means no connection, T stands for triggers, O is output, NC no connection, reset again no connection, then control no connection, threshold no connection, discharge no connection, and VCC. So these are the terminals which you have in case of a 14 pin IC. This is not different functionally from the earlier one, only thing is it is designed in a 14 pin IC. Now there are other timers also. For example, I would like to mention here 556. This is a very important IC, and the speciality about this IC is that this has two 555s inbuilt. So there could be 2 timers inbuilt in the same capsule. So this is very useful. You can have 2 ICs, 2 timers taken out from one IC only. So this is all about the timers, and we have to check again the configurations very correctly. If you do not know the configuration correctly, then you cannot put it in the circuit rightly. Now the next one is of course the optocoupler. You can see it here. You see, this is an optocoupler. Again, it is a 6-pin IC you will find, 6-pin IC. I have got in my hand also. You can see there are 3 pins at the top, there are 3 pins at the bottom. So, in all it is a 6-pin IC. Optocoupler, as the name indicates, it is based on opto, means light, and of course coupler means it is a device which will couple 2 electrical circuits based on light. So, light is the basic funda for this device. There are 2 basic components in this IC. One is the LED, the light emitting diode, and the other is the phototransistor. These 2 are inbuilt in this device, and the most commonly found optocoupler in the market is MCT2E, which is a 6-pin IC, as I have shown you. The configuration is like this. Suppose 1, 2, 3, 4, 5, 6. This is pin number 1, 2, 3, 4, 5 and 6. Between 1 and 2 there is the first component, which is LED, and it is connected like this. That means anode is connected to pin number 1, cathode is connected to pin number 2. At pin number 3 there is no connection, NC. Between 4, 5 a phototransistor is connected like this, whose emitter is connected at 4, collector at 5 and base is open. Now, as soon as, because there is a groove here, as soon as you get input at this point 1, positive input, this LED gets forward biased and it will start conducting, thus emit light. This light, when falls on the base, the transistor will get energized and start conducting, and thus this MCT2E, which is an optocoupler, will be enabled and it will start functioning. Now, the next component what we are going to discuss here is the regulator. You see, there are so many regulators here, which I am going to discuss now. Right. Regulator, here of course you can see the regulator looks like okay. It looks like this, and what does it look like? You are familiar with this. Earlier we saw that it looks like a, what is that? It looks like a plastic pack SCR or a plastic pack triac. Yes. Now there are 3 terminals coming out. The terminals are marked like this, 1, 2 and 3. 1 is the input, 2 is ground and 3 is the output. Since it is a regulator, regulator means it gives a regulated power supply, is it not? Regulated power supply, that means a constant voltage supply is to be obtained at its pin number 3, which is its output terminal. Now, since regulated power supply means it is considered to be DC, how do we generate DC? Okay. So, you have to give some input at 1, 2 is to be grounded and 3 will be a regulated supply. We will see later How do you generate it? Now first of all, we should know that a regulator can be of two types. It can be positive voltage regulator and it can also be negative voltage regulator. The positive voltage regulator is the 78 series. So if you have 7805, it means it is plus 5 volt regulated supply. 7806 is plus 6 volt. 7809 is plus 9 volt. 7812 is plus 12 volt. 7815 is plus 15 volts and so on. It goes up to 24, I think. Yes. Similarly, you can have a negative voltage group also which starts with 79. So if it is 7905, this means minus 5 volt. 7906 minus 6 volt. 7909 minus 9 volts. 7912 minus 12 volt. 7915 minus 15 volt. 7918 minus 18 volts and so on. So you can have all sorts of regulated power supplies both in positive group also, in negative group also. So how do you generate it? There could be a very simple circuit. I will try to explain it. You see, I will have a transformer first, which has to be a step down because this is 220 volt here, single phase. Output will depend how much you need. Suppose we need a 6 volt supply, so it has to be 6 volt. That means 220/6 volt. So 6 volt will come here. Then I put a rectifier, I connect it here, I connect it here, this will be output, here diode is connected, a diode is connected here, one diode is connected like this, another diode like this. This becomes a full wave bridge rectifier. This will be the output and here we will connect say 7806, which will give me 6 volt output. This is for ground and this is the output. So if I find out, this is my V output. So is it clear? I have given a single phase AC supply to this 220/6 volt step down transformer. I have got it 6 volt AC here, then through this bridge rectifier circuit I got it 6 volt DC. Now this is given to this 7806 and the output is V output, which has to be regulated 6 volt. If I want to nullify the ripples, I can put a capacitor here and also a resistor. This does not mean anything special, this just forms a filter circuit. So filtering is done and here you will have a very good DC regulated voltage as output. Now same thing can be verified here experimentally also, and here we have rigged up a circuit for 15 volt regulated power supply. Let us see what I have done here. Now we are going to verify the same thing experimentally. Here you see I have rigged this circuit on this breadboard and this is a step down transformer which is being supplied by this variac. There are two multimeters. One is connected to the input of the regulator, which is a 15 volt regulator, and the other one is connected to its output. Now the output of this transformer, which is step down, is coming to these two diodes, which is making the rectifier. This capacitor and this resistance, they are forming the filter circuit, and this resistor is connected at the output of this voltage regulator. Now when I give a supply, you see I am increasing the supply, the input and output both are changing. Here when I give a 230 volt supply to it, the input is 16.93 volts DC and the output is 14.98. If I still increase it, you see the input is changing there, but the output here of the voltage regulator is not changing. Now what does it mean? This shows that it is a regulated power supply and there is no change in its output even if you change the input. Okay. Now the next component what we are going to discuss is the 7 segment display. Here you can see 7 segment display. Now let us explain this. Seven segment display. As the name indicates, it is a kind of display and there are 7 segments. If I draw the segments, it can be drawn like this. One, 2, 3, 4, 5, 6, 7. But if I join them, you can find that an 8 can be written, a 5 can be written, 4 can be written. So digits from 0 to 8, also 9 can be written with the help of this display. It is a very popular display used in electronic circuits. Now let us see what are these segments stand for. They are A, B, C, D, E, F and G. A, B, C, D, E and F and G. Now the segments can be, if I go to the IC, there is one LTS 542. This is very commonly used IC, 7 segment display, and this is common anode type. There could be another type of 7 segment display which is common cathode type. Now let it be clear what is common anode and what is common cathode. If these are nothing but a kind of diodes only, they are LEDs, so they will have one anode, one cathode. If I make all the anodes common, then it will go to the positive supply and it will be used for a positive supply. If I make on the other hand the cathodes common, then it will go to the negative supply. So that will become a common cathode type of display. Now the numbering is very, very important. You have to know them very clearly, otherwise you will make an error in connecting them in the circuit. So the numbers are like this. You will find that this is a 10 pin IC. So numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 is E, 2 is D, 3 is VCC, 4 is C, 5 is no connection, 6 is B, 7 is A, 8 is again VCC, 9 is F and 10 is G. I will repeat. Pin number 1 stands for E, pin number 2 stands for D, 3 stands for VCC, 4 stands for C, 5 there is no connection, 6 stands for B, 7 for A, 8 for another VCC, 9 for F and 10 stands for G. So if you know these configurations, these numbers, you can easily connect them in the circuit. Now with this we have finished the general purpose ICs which are generally used, commonly used in the field of electronics, in the field of power electronics, any field of electronics, such ICs are very commonly used. So friends, in these 4 programs we have discussed about the basic electronic components, the power electronic components and the general purpose ICs. Thank you.